These are the 5.3 notes for PreCalc. Today we're going to talk about exponential functions and what they look like if they are graphed. So our first question is, what do exponential graphs look like? So I'm just going to draw out two graphs here. And an exponential graph is when something starts off kind of small and then gets large very quickly. We'll also be working with a negative version of those where it starts off small and then again gets large very quickly, but in the negative direction. We're going to start with two basic graphs, y equals 2 to the x, and then at the bottom, y equals 3 to the x. So I've chosen some numbers for x, just some really basic numbers from -3 to +3. And what I'm going to do is I'm going to plug those in for the x right here. So in your calculator, you would do 2 to the -3rd. And then you do 2 to the -2nd. You do 2 to the -1st. So we're simply plugging it in for each of these x's. 2 to the 0, 2 to the 1st, 2 to the 2nd, and 2 to the 3rd. Remember, make sure you have the Calculator app downloaded on your phone or another sort of scientific calculator on your phone. You also should be able to use the calculator on Google if you just type in 2 to the -3. All right, so for the first one, I'm getting 0.125. Then I'm getting 0.25 and 0.5. Very small numbers there. And then when I plug in a 0, I get 1, 2, 4, and 8. So what I'll do is I'll graph each of these points, keeping note that all these with the decimal are just going to be somewhere between 0 and 1. So as I plot -3.125, it'll maybe be about right there. As long as you put it between the 0 and the 1, you're good. Same thing with the -2.25. Yeah, -1.5. It's hard. You can't even hardly tell the difference between each of those points as long as they're between 0 and 1. Then my numbers start to get into whole numbers, a little bit larger, which is good. 2, 4. And finally, 3, 8. And you'll notice you've got this sloping thing here that kind of shoots up towards the end. Exponential graph. On this graph, we have two things, domain and range, and then technically a third thing was a horizontal asymptote. We're going to talk about our domain and range first. The domain is what x's you are allowed to plug in. I chose these x's here just because they were smaller numbers, but you can go as large or as small as you want to. Because of that, we're going to say that the domain is all real numbers. All real numbers. That's the R with the capital stick. So remember, you could kind of write it like this if you wanted to and fill that in. That's fine. For your range is where your y's are. And no matter what numbers I plug in here, I'm never going to get a negative. When I plugged in -3, it got me a small decimal, but it didn't give me a negative. So my range, all my y values are going to be greater than 0. The last part of this is what we call a horizontal asymptote. We learned about horizontal asymptotes a couple chapters ago. We were trying to find the HA and OA. We had that big chart. So the horizontal asymptote for this one is going to be right at 0. None of my graph ever goes below 0. It gets really close. That 0.125 is really close to 0, but it doesn't ever quite hit 0. So I'm going to say that my line is y equals 0. Okay. So then we're going to take a look at the next one, which is going to be very similar. We've again got these numbers on the left-hand side, and we're just going to plug them in. So 3 to the negative third, 3 to the negative second, all the way down. And just take a moment and see if you can find those answers. The decimals, if you want, you can round them. But take a second and type those into your calculator. So I'm just going to round to a couple decimals here. On this first one, I'm going to call that one 0.037. The next one, I get 0.1 repeating. I'll just call it 0.111. The next one, I'm getting 0.3 repeating, 0.333. And then finally, when I get to 0, I get up to a whole number 1. And then 3 to the first is 3. 3 squared is 9, and 3 to the third is 27. So notice that same pattern with the first 3 numbers being very small. We'll plot 1, 2, and 3. Those are going to represent those first 3 decimal numbers. And then finally, when I hit 0, 1, I can start getting into actual points that I can graph a little bit easier. This one's a little too big. It doesn't fit on my graph. So we'll just go ahead and swoop up this direction. And if you compare the 2 graphs that we've done so far, you'll notice that the first one is just a little bit, the second one is a little bit steeper. It goes up at a sharper angle, as opposed to the first one, which is going up slightly. And then this second one almost looks like it's going straight up. That corresponds to this number right here. So the higher that number is, the steeper the graph is. Our domain is going to be the same, all real numbers. My range, you can again tell that the entire graph is located above the 0 line, so y is greater than 0. And if we were to draw that line for our horizontal asymptote, you'd have it right here across at 0. Y equals 0. This number here and that number there are always going to be the same. So those are your basic graphs. What we're going to do now on the back side is we are actually going to graph these and shift them. So on the back side, we've got some things to fill in. The first one, this is what our functions look like if they are exponential. B is what we call the base. The base is going to tell us how steep it is. It helps give us the pattern. Then the negative in front, notice there's no negative here, but if there was, it's going to flip it. And then the H and the K are a lot like the numbers we've worked with before. It's almost like you can have a parenthesis right here, and that H means you're going to move it right or left. But just like always, it's going to be the opposite. And our K, we'll move it up or down. And now it's going to be just what it looks like. Positive will be up, negative will be down. Okay, let's take a look at example number 1. We've got the graph here, 2 to the x. Remember, 2 is going to help us with a pattern. We'll get to that in a minute. What we want to do first is find our horizontal asymptote. This right here is going to help us with that. Our horizontal asymptote is going to be at y equals 3. So I'm just going to draw my line at y equals 3. Then I notice that my graph is positive. There's no negative in front. So my graph is going to go above. Kind of this shape. And so what I need to do now is look for my pattern. My pattern is going to be created by using 0, 1, 2, 3. I'm just going to plug in a couple of different numbers. So if you notice back on the original here, this is the very first number that's going to get us a whole number, 0, 1. That same thing happens right there. For every problem, my first number is going to be 1. That's the same as having 2 to the 0. To get the rest of the pattern, you're just going to keep multiplying by 2, because that's 2 to the first. Multiply by 2 again. That's 2 to the second. Multiply by 2 again. That's 2 to the third. So what you're really doing is you're creating a very small table in your head and then getting the numbers 1, 2, 4, 8. So I'm going to start with my line. These numbers represent how far above the line, above the horizontal asymptote. So I need to go 1 above the line and put a dot. When I read graphs, I always read towards the right-hand side, just like I read words. So I'm going to scoot over, and then I'm going to go 2 above the line to represent this 2. Then I'll go 4 above the line. Then I'll go 8 above the line. That puts me off the graph. To the left would be your decimals. So you're just going to go right between to represent your decimals, and then straight up. So this 1, 2, 4, 8, again, is representing how far the blue dot is from the pink line. Your domain, again, and always, is going to be all real numbers. And your entire graph is located above the line 3. So y is greater than 3. Let's look at example number 2. Here I've got 2 extra numbers happening. I'm going to start with this -5. That's going to be my horizontal asymptote. Y equals -5. And I'll go down 5 and put a line. Next thing I'm going to do is I'm going to work with my pattern. I started with a 3 here. That's going to help me with my base pattern. Remember, the first number is always 1. Anything to the 0 power is 1. And then I just keep multiplying it by 3. 1 times 3, times it by 3, times it by 3. Those again are representing 3 to the first, 3 to the second, and 3 to the third. Another thing we have to notice is that this x minus 4 is going to tell us to move right or left, but it's going to be the opposite. So I'm going to move to the right 4. So instead of my first dot being here in the middle, right above it, I'm actually going to move that dot to the right 4 places. 1, 2, 3, and 4, and my first dot's going to land right there. From there, you would scoot over, again, moving forward through your graph, and go up 3 to represent this 3 right here. Then from the line, you'll go up 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 27 is too large. It doesn't fit. And remember, anything smaller than that would be decimals. So keep in mind over here as you plot, make sure you go in between those lines to represent the fact that you would have had decimals, just like we did on the beginning of our graphs. Domain is always all real numbers, and my range, y, is greater than -5. For this next one, notice there's nothing here. That's going to be 0. So I'll put a line right across at 0. The 4 is going to help me get the pattern. I always start off with 1. And then I just keep multiplying by 4. Multiply by 4 again. And I know 16 I'm going to run out of space. So that's as high as I'll go on that one. But those are coming from 4 to the 0, 4 to the 1, and 4 to the 2, if you want. This little number up here, this x plus 2, is going to have me move opposite direction of what it looks like, left 2. So instead of starting in the middle right here, we're going to move that left 2 places. We'll start right here. That's the 1, noticing that the blue dot is 1 above the pink line. Now the next place over I go, I still want to move to the right. I always move to the right in math. So from the pink line, I'm going to go up 4. From the pink line to the blue dot, 4. 16 is not going to fit, so I'm not even going to worry about that. And then remember, your smaller numbers would be your decimals. So start off in between your lines and then go straight up. Very steep line there. Domain is always going to be all real numbers. And your range, your entire graph is above the 0 line. Y is greater than 0. For our last problem, we'll deal with a negative. But I'm going to start with this plus 2. That's going to move my horizontal line up to positive 2. After that, the 5 is going to help me with my pattern. So I start with 1, always with 1. And then I just keep multiplying by 5. And I know 25 is not going to fit on there, so I know I can stop. I just see an X there, which means I'm not going to need to go right or left at all. But I do see the negative, and the negative means I'm going to have to flip this. So instead of it being above the pink line, it's going to be below the pink line. In fact, 1 below the pink line. Move forward in your graph to the right and down 5 from the pink line. Always count back to the pink line there. And then again, representing your decimals right in the middle there. Your domain, all real numbers. And your range, y is this time less than, because it's below the line, less than 2. So make sure you use that less than sign when you're doing below the line. All right, that's it. If you have any questions, let me know. I'll be on Google Meets tomorrow.